In this video, we will discuss about TCP headers. TCP header information is added at the layer 4 on the transport layer. So when the transport layer sends the packet down to the network layer, it adds a header and header part to that packet. Right? So we are going to see what information is added by the transport layer into that header and what is the size of that TCP header. So the TCP header size it varies from 20 to 60 byte. So minimum will be 20 byte and maximum it can go up to 60 byte. This this uh, this it becomes of 60 byte because of additional 40 bytes which are contributed by the options here. So the main component in a TCP header are source port and destination port. As you know that on the transport layer, we add source and destination port information. Both the source and destination port, they are 16-bit fields. So all these lines here, these rows, each contains say 32-bit value, except the options. Options will be 40 bytes. So source and destination ports will be added. Then we'll have a sequence number. The sequence number is a 32-bit field, which indicates how much data is sent. So sequence number is something that is generated during a TCP handshake when we do SYN-ACK. So a random sequence number is generated. When you look at a capture in the Wireshark, so then you will see that the initial sequence number is set to 0, but the sequence number is never actually 0. So when you look at the actual sequence number, that will be a random number. But these tools like Wireshark, they show you initial sequence number as 0. That you're looking at is the relative sequence number. So that is just for the purpose of displaying it nicely and make the capture readable so that you can relate things. That let's say the initial sequence number starts from 0, then how can you follow along with the packet flow there, right? But the actual sequence number will never be 0. Acknowledgement number is also a 32-bit value similar to the sequence number. Acknowledgement number is sent by the receiver. Once you have sent something, then the TCP acknowledges it with an acknowledgement, right? And with that acknowledgement, it says that I've received your data till this number, and now I need you need to send me this one. So it does that with the help of acknowledgement number. Acknowledgement number is calculated with the help of sequence number plus 1. So then the receiver says this is the next data that I need. So I've received till here, till this sequence number, and start sending me from the next one. Then we have data offset. So data offset is if a 4-bit value. It tells that what is the length of the TCP header. When the transport layer sends it down to the network layer, the network layer has no idea what's inside, right? Whether there is a header or a data. This data offset bit, it helps to figure out what part is the TCP header size so that the receiver knows where does the actual data begin. That is the job of the data offset bit. Then we have some reserved bits here that are always set to 0. There are 3 reserved bits. Then TCP has some flags. There are total 9 flags, but we will only talk about the most important ones. The most important flags are, we have urgent flag, URG. So if urgent flag is set, then it's telling that the data should be prioritized. Right? Then we have push flags written as PSH. So when this push flag is set, it tells the application to immediately push the data, to immediately send the data. And it tells that do not wait for the TCP segment to full. As soon as you get it, you need to send it because the push flag on this data is set. So the application wants us to send this data immediately and not to wait for the complete segment to be created. So the transport layer will immediately push that data. Then we have reset. So reset is a flag that tells that the connection has been terminated, but not in a good way. So normally when there is a normal connection termination, you will not receive reset. So if you're receiving a reset flag, that means the connection was abnormally terminated because of some unknown reason. Reset is not good. Then we have fin. So fin is the finish. Fin is the way to gracefully terminate a connection. So either the sender or the receiver, when they need to terminate a connection, they send a fin that I need to finish this. We need to finish this connection. Then we have SYN. SYN is used in the TCP handshake, right? So it helps to generate the initial sequence number, the random number. Now let's take a look at the Wireshark capture, which shows you how can you relate all this information in the real time. So you're looking at a Wireshark capture here, which shows you the transport layer information here, the transmission TCP, right, where you can see the source and destination port added to the TCP header. Then we have sequence number. So you are looking at the sequence number in Wireshark. It shows you 0, and then it clearly mentions that you're looking at the relative sequence number. So that is not the real sequence number. The real sequence number will never be 0. It will be a random number, right? Then we have these flags, the TCP flags. You have 9 flags. The most important ones are urgent, acknowledgement, push, reset, SYN, and FIN. And in this particular example, you can see the SYN flag is set, which means this is the first packet of the TCP communication. So when TCP communication starts, we do SYN, SYNAC, ACK. So you are looking at this particular SYN packet here. Only this packet will have the SYN flag bit set to 1, and all others will have the SYN bit set to 0, because that is not a SYN packet, right? Then we have window size, how much data a receiver can receive, right? Then we have checksum, we have urgent pointer. So urgent pointer will only make sense if the urgent bit was set to high, right? Then urgent pointer will help us figure out what where does the urgent data end, how much part of the data is urgent. Then we have some options. So options is really optional, and its size varies from 0 to 320 bits. Right now in the options, we have 4 byte of data here, which is TCP MSS value, the maximum segment size.